Good afternoon. Welcome to the Smart QA Musings, which is a gentle flurry of interesting thoughts. Today I want to muse about the role of mental models and how Gen AI can assist us, and then look at the future of smart assurance today. So, when we talk about mental models, what we really ask, what we're looking forward, what the discussion or what the musings is all about is, it's a bit of a journey into the inner frameworks, the way we think, the way we model, the way we visualize in the mind's eye, and how the new intelligence that is available from the machine, the artificial intelligence, how our inner frameworks and the new intelligence are at a kind of reshaping the way we deliver quality. And that's what I want to muse about today. So truly, when we talk about assurance, it really begins in the mind. What that means, what do we want? How does it work? How may it work? What kind of issues could be probable? What should it meet? So truly speaking, assurance is a good, assurance, a smart assurance is really about how we probe, and that begins in the mind. And that normally is guided by the models that we carry. And therefore mental models are really great instruments, because what we are doing is we are seeing the invisible. And the way we see the invisible is to make it visible by questioning, by probing. And that is really the role of mental models. So what I want to do is to kind of list down some mental models and see how it correlates to what we do, and how, the new Gen AI today, how can it offer new ways to make this invisible visible? How can it help us question? How can it help us probe? Remember, this is the step before the actual doing, the actual validation. And therefore that really brings about the fundamental topic of systems thinking, where systems thinking is about seeing the larger picture, seeing the interconnections. And therefore, systems thinking models become fundamentally very important, right? And systems thinking is about consists a variety of different models. I've tried to put in some that might be of interest to us. This is not necessarily the comprehensive list of all the mental models. So it is about seeing the interconnections by feedback loops, like the mental model of feedback, where we're saying, hey, okay, where is feedback occurring in the system? How are they connected? Where does it control? Where does it reinforce? And so it could be a positive assurance feedback, a negative assurance feedback. So we're trying to kind of understand the larger system of where is feedback happening, how does it stay? The second kind of a mental model which is titled as stocks and flows, is primarily about where are things produced, where are things consumed. So stock is about collection. It's about things that come. So it could be a set of messages, a set of requests, a set of data. And so we are really looking at it from where is it getting produced, where is it getting processed, and therefore we are trying to see if the system is flowing well. And therefore the mental model of stocks and flows give us a sense of a behavioral model of the flow. The mental model of leverage, or points of leverage, is really asking, okay, where are points which might be giving us leverage? What if you do? For example, you could change some setting, and that setting has a probably interesting ramification. Maybe it could slow down. Maybe it could speeden up. Maybe it could cut off something and then we don't understand. So leverage points are basically is the idea of a mental model, where we're looking at what parts of the system may affect other parts of the system pretty seriously, both negatively, but more often when we use the word leverage, we're looking at it from a positive sense, right? So what are we trying to do here with these mental models? We're trying to use the systems thinking mental models to see interconnections and therefore get a larger picture of how systems are controlled, how systems flow, how systems react to certain leverage points. Right? And highlighting these emerging risks and suggesting where to probe can be aided because we may not understand everything. So we can interact with the Gen AI system, giving it some information. Maybe it gives us some hints and ideas, and therefore in some sense it can highlight certain potential risks. Maybe it can suggest where to probe, and that's how some of these models can be aided by Gen AI. But what is important to understand is the human prioritization is relevant. It is not that the Gen AI is going to do anything magical. I'm quite sure we appreciate that. Right? The second part of stuff is about we all need to make decisions and then move on. Make decisions and ask more questions to make decisions and so on. But most of the time, the decisions that we make in the context of project and assurance at the lower level is not always with complete knowledge. It is recognizing the Johari window, which is called the knowns and the unknowns, where we say there is known and unknown, and I know and I don't know. So when you look at this as an x-axis of I know or I don't know, and the other one is the known and the unknown, you get 4 quadrants, and this is called as the Johari window, which says I do not know that I do not know. I know that I know. I do not know that I know, and stuff like that. Right? So these 4 quadrants are probably a way by which we slowly try to find out what we know, what we don't know, and therefore seek information to clarify and probe, which is what primarily assurance is. So the mental model of knowns and the unknowns, inspired by the Johari window, is something that we become what we use from a cognizance of knowledge, so that we can seek and go forward. The other ones, which are primarily knowledge from a risk standpoint, is about FME, or failure mode evaluation analysis, where we look at it from what are potential failure modes, and we are hypothesizing certain failure modes and trying to find information that if it could be possible, what are the probabilities and what are the possibilities. So failure mode and evaluation analysis is a standard QC model, a quality control technique, a quality control tool, really, a mental tool, which helps us identify what are some failure modes and what are things that can happen, and then you construct a model and then say, okay, how can I alleviate? So it is from a risk analysis model. Right? And therefore we are trying to make decisions of where we need to strengthen, what we need to take care from a variety of different aspects, from the notion of architecture, the coding, and so on. So failure mode evaluation analysis is typically done certainly in large control systems that have safety. So whenever you look at any safety system or control system, you would find FMEA becoming a part of the systems analysis. I'm sure a lot of us understand the notion of principle of Pareto, where we say, look, I always look at it from 80-20 kind of a rule, where I say, what is it that I know? Is it 80% or 20%? So we use it for a variety of different things. Most often we use it from a principle of prioritization, because we can't really wait for the entirety. So we kind of look at this 80-20 rule, and Pareto basically says, look, focus on the trivial few. So sometimes we normally understand that 20% contribute something to the 80% of the effect. So we look at those 20% rather than trying to focus on all the other 80%, which might only have a bearing on the 20%. So I think that's how we use the principle. So the Johari window of knowns and unknowns, the risk mechanism of failure mode evaluation analysis, and the principle of Pareto helps us constantly make decisions and go forward, especially when our knowledge is limited, and we, as a tester, as an assurance specialist, we are always looking for something. It is not that everything is given. So there is always a sense of incomplete knowledge. So where does Gen AI help? It helps us to kind of surface these hidden patterns and suggest overlooked interactions. So how does it help us? Having this mental model allows us to figure out some questions and use Gen AI to find some information and therefore allow us to understand knowledge what we don't know and allow us to make decisions. Now remember, in any form of, when we use Gen AI, what we're really saying is unless there is a good theoretical underpinning, unless there is a good model, it's difficult to ask meaningful, sensible questions that help us guide. And Gen AI helps. Using some of these ideas, I can use it to surface the hidden patterns, suggest overlooked interactions. But again, remember, this insight comes from human curiosity. So which means if I'm curious enough, aided by some of these mental models, then I'm able to exploit Gen AI much more meaningfully. Right? The other idea that we can look at from mental model is, how can I sharpen the thought? How can I get better? And therefore, some of the ideas could be like saying, okay, whenever we analyze any problem, we want to look at it from breaking down the problem from a fundamental principle rather than guesses or only experiences or only habits. Of course, all of us have a lot of experience, all of us are habituated in doing a few things. And first principles as a mental model simply says break the problem to its basic truths by reasoning. It's not about just following conventional wisdom. It is not about ignoring inconvenient assumptions. It is really about asking, how do I test this? What does it do? And therefore you constantly look at it from a first principle perspective. Right? And therefore the way we build upon test ideas are based on or built on fundamentals, not just habits. And therefore they lead us to a more deeper, more original way of probing. Right? And how does it help us? It sharpens the thought, and that's how it works. The second one is about the observe, orient, decide, act, the OODA principle, the loop. What does it simply say? It simply says we are iterative, we are continuous. Right? And this was, in a way, the mental model was developed by a gentleman called John Boyd, who was a fighter pilot, to allow us to rapidly think and rapidly adapt. Right? So we are not talking about it from just intellectual breakdown, but constantly about reorientation. So what does it mean in the context of assurance? We constantly observe, we gather data, we gather signals, we orient, that is, we interpret in the context, and we decide. That means we figure out probes, we figure out hypotheses, we conduct some stuff to evaluate, and then we explore or test. And then we loop it back. So constantly we are in this wonderful loop, which is observe, orient, decide and act loop. And quite obviously, if you are an exploratory tester, beyond the realm of a typical scripted testing, I'm quite sure you understand. If you are a troubleshooter, debugger, you certainly understand, because we know adaptation is important. Right? It's not just about having a fixated notion. The third model of an inversion simply says, like, instead of looking at the problem, we invert it, we flip it. Instead of asking, how can I make this work, you might really ask, how can I make this fail? So inversion principle, inversion as a model, all it simply says is, look at the opposite, right? And therefore, we're looking at the unknown unknowns, right? So rather than confirming an activity of a workflow, for example, we might be asking, what are ways I could break it? What are assumptions violated that could cause havoc? So you come from it from the other side. And therefore, this in a way helps us to be more creative, more robust, risk-oriented approach rather than a conformance-oriented approach. This is also a mental model that we possibly use, right? So the ideas of first principles of logically breaking it down, the model of OODA, which is about constantly adapt, and the inversion where we look at it from the other direction of what if, the other side rather than conformance, helps us to sharpen the thought and therefore assure more deeply. And how can Gen AI help? We can kind of use these ideas and mental models to generate probably interesting alternative scenarios, surface assumptions. So remember here, we are not using the Gen AI in the typical sense of, give me scenarios or give me test cases. None of those. We are using it from from seeking information based on some of these ideas and mental models, and then trying to probe much better. But again, remember, it's again based on our mindset, and that is why models become important. So the reason why I highlight on the second line, which is unhighlighted, is I want to re-emphasize the fact that I think the human's role is important. It is not a machine's role, and therefore it's about how we probe, how we ask questions, how we converse with, and how we adapt and adjust based on the answers that a Gen AI gives us. So this is about the sharpening of the thought. I think this we can easily relate to the act of modeling in the context of design. Representing specifications in a more formal model like a state machines, which is a behavioral model, an entity relationship, which is a model of data, the idea of abstractions where we can abstract the system, abstract the flow, abstract the active evaluation into small parts so that we can decompose the problem and understand it better, are all mental models. And these are something that I'm sure we relate. And I'm sure there is a lot more of these mental models which are available as tools today. Representation of specifications, which is what state machines are here. And there are many, many of them. But the idea here is mental models play a significant role in design and modeling aspect of a problem solving, because they bridge the abstract ideas into real system behavior. How can a Gen AI help? Now, if I have these models well into thought, then maybe I can ask some interesting questions about a feature, about a system, by saying, hey, here is what it is. What do you think could be a representation of this in a state machine? What are events, and so on and so forth. And in the process, surface certain hidden patterns, such overlook interactions, and so on. But as again, insight comes from human curiosity, right? And therefore, these mental models and many more of them are useful for the design and modeling space. So as you can see, we've been progressing from the various life cycle aspects of what we do as assurance, and we're trying to examine various mental models of interest in the various phases of the life cycle. Coming to the latter part, it's not about just finding defects, right? We're always interested in why did the defect creep in? So you're always doing some kind of a cause. We're doing cause-effect analysis. We might say root cause. We might map it. We might do gap analysis. We might do Pareto analysis. And so what are we trying to do? Remember, we talked about OODA some time ago. We are constantly observing these defects. We're not just focusing on fixing the defects. We're also interested in understanding why this happened, what could we do better, and adjust the process and adjust the practice. So I'm sure we appreciate some of the ideas of root cause and so on. So what is systems mapping? It is basically trying to chart out where do defects emanate from. So maybe you want to visually figure out, okay, here are the components, here are the modules, here is how the flow is. So you're abstracting the system and then saying, okay, here if I'm mapping the defects to various parts of the system, maybe I will get a semblance of what areas might be weaker, right? And we're not talking about code, we're talking about the more bigger picture, so to speak, of the system. And so systems mapping is maybe mapping the system into its components, parts, dependencies, stakeholders, interactions, and so on and so forth, right? So how does it help us? It helps us as assurance people see the bigger picture, understand the web of relationship which are normally intricate, and therefore we can find out certain integration points, certain weak areas, certain areas from which defects may be cascading from, probably areas of complexity, spot out certain critical parts. And I'm sure that if some of you have probably done performance testing, it's something that we use because we want to find out where is the bottleneck, right? And therefore, complementing it would be also Pareto. because there would be a lot of things to look at, but then you find the critical few that could have a bigger impact, right? And that's where some of the leverage point that we talked about comes in handy too. So gap analysis is more like finding out a more of a structured approach to find out the current state against the desired state and help us find out what is missing. Could be in the context of coverage, it could be in context of certain flows which were untested or certain requirements which were undocumented, more to highlight certain discrepancies. So we are trying to constantly ask ourselves, where is the gap? I'm sure if some of you have been doing auditing of a process or a practice or a system at large, you would always use the word gap analysis. Where are we today? What we should be there today, and therefore what is the gap? And therefore try to find out how to prioritize improvements. So more often all these root cause analysis, gap analysis, Pareto analysis, systems mapping are all interesting mental models which ultimately become tools of the mind, where they look at defects, but it's not about finding, it is about understanding deeply so that we can do something in terms of improvement. And again, this is all about surfacing certain patterns, finding out certain root causes, and make sense. But remember, sense making still remains a human art at the end of the day. So we started off with a larger level of understanding from a systems thinking, went on to the various aspects of life cycle, and currently now we are in the analysis and improvement, if you will. And finally, in some sense, to close down the improvement models, there are various improvement models. Some of you, I'm sure you probably heard about it and use it: Kaizen, theory of constraints, Deming wheel or PDCA. All these are models for characterizing systems and driving it for improvement. So the PDCA, or the Deming wheel, which is basically the Deming philosophy, simply says plan, do, check, act. Which simply says plan, do, check, and act is basically a model of continuous improvement, which is what Japanese adopted. Kaizen is a very Japanese thing, right? Kaizen simply says constant, continuous improvement in a very small manner. So we're not talking some big bang improvement. It's about incremental changes, very small, rather than major overhauls. That's the idea of Kaizen. So it could be practices of testing, processes of testing, small improvements in the product quality. It could be tiny refinement of test cases, maybe automating some parts of it, having brief retrospectives. And what we're really saying is small tweaks to add continuously. So we're not talking about some big bang stuff that we are doing every 3 months or 6 months or yearly and so on. Theory of constraints is a very interesting stuff. It has roots in manufacturing, where they're looking at what are those constraints in a larger system that ultimately block. So it focuses on understanding constraints in a flow, and that's how it came into manufacturing system. So you will find an amazing book that is written by the author of Theory of Constraints. He's an Israeli author, and what the book primarily talks about is, and what the entire idea talks about is, identify those constraints and find out where the constraints, what are the causative factors of the constraints, and then unblock them, right? So we are really looking at it from a bottleneck perspective, which might be related to slow execution of stuff or a flaky environment, or so we are looking at improvements from constraints and then try to unblock them. And so one of the constraints that I use in my methodology from a consulting standpoint is constraint of capacity. How can we unlock capacity? So if I'm doing too much of testing, or I'm doing somebody else's work as testing, maybe that's a capacity constraint. So we're looking at it from, I think we briefly touched upon leverage points also, where a small shift can lead a big value, right? So we're trying to find out those tweaks that could give us a bigger twist. So the idea here is, there are well-formed mental models, many of them, some of which has been reflected here, where we're talking about these mental models which ultimately drive change and not just detection. And therefore, all we're doing is we are probably exploiting, maybe some aspects of Gen AI and prompts to be able to look at some data, analyze, do some analytics, maybe monitor some outcomes, suggest optimizations. But again, the direction and change are really steered by our human intent. And that's where I think we come to the end of the models in various phases of the life cycle that we have. I've got a couple of slides. I'll probably take about 2-3 minutes before we close down. So the final take is, on one side we've got great mental models that's kind of interesting to look at various aspects of the life cycle. Right? Could be from systems understanding, planning and risk reduction, design and modeling, analysis, improvement, and so on. But when these models meet the machines, there is a very interesting promise and a very interesting challenge of partnership. And therefore, it is not about just using Gen AI because it is something interesting and cool, but really it's about having a good grounding in some of the mental models and being able to appreciate it because they set the direction, they frame the meaning, they anchor the relevance. And once we are well grounded, then we know what to look for. And we are able to watch ourselves in terms of what we know, what we don't know. We're able to reframe questions in terms of, not looking at it from the known stuff, but also from the inversion standpoint. We are able to dig in and figure out whatever. And that is when I think, being able to do that, the advantage is the Gen AI helps us scale, helps us speed, and helps us surface some of these unexpected information far more rapidly. And remember, don't forget the OODA loop, right? We're constantly observing, adjusting, detecting, and analyzing, and constantly adjusting. And so the connection of the human endeavor, we are driven by mental models, and the machine challenge and expand the entire realm of our understanding, surfacing the clarity, which is what smart assurance is all about, right? And therefore, we can really reimagine the way we look at smart assurance, because the biggest leaps that we probably have, and as what a lot of people predict, is when the co-creation exercise. It's not anymore just using the machine as a slave. It is about co-creating our with the machine. And that, I think, is happening in a variety of disciplines, and therefore we are no different. So the whole idea of co-creation in terms of programming, I think, which we are well aware of, arts, in terms of production of content, and I'm sure you can see a variety of applications today. So co-creation is a word. So, but the role here is mental models guide and Gen AI amplifies. And therefore the qualities is no more from checklists or checking and stuff like that. It is from a very beautiful, creative, symbiotic partnership, very critical too. So assurance is no more just a staid, boring thing. I think we entirely have to change the way we look at assurance, because it's, if the code is generated in some sense by a machine augmented by a human, are we really testing code is the bigger question that we have to ask. And hopefully we will have an interesting webcast on it, maybe in the later part of August or September, with somebody else whom I would love to interview, because it becomes a very living, anticipatory practice. It's no more just a staid, boring practice. And that is where I've been focused on a methodology called HiBIST for many, many years, probably for more 2.5 decades. And the latest version of the methodology, which I call as HiBIST, is basically a methodology driven by mental models that ultimately become key concepts which form the hypothesis-based core method to analyze and design. And some of those aspects which are not the analysis and design but the act of doing, the notion of immersiveness, are driven by certain practices. Again, practices inspired by some mental models, but more often from a behavioral practice, which is what the second part is. They do immersively in sessions. So HiBIST is one such methodology driven, or trying to use certain mental models as part of key practices, and therefore I consider it as one such methodology for smart assurance. So I just wanted to kind of say this is what I've been primarily focused for many, many years, and now I'm absolutely excited of how we are able to marry the power of Gen AI, and that's what we're trying to do in our tool, Do Smart QA itself. So as we come to the end, muse on these. to ask yourself, what are some of the mental models that guide your assurance? How do you view them? How are you letting AI stretch them? How are you exploiting the Gen AI today in your context of assurance? Because assurance is no more about the classical way of doing things. And ideally, and then ask how do you or how will you nurture this symbiotic practice of models and methods and methodologies with the machines, and how do you nurture this nurture this partnership of human and machine in your own practice, maybe in your personal practice, in your team practice, and so on. Because we're not talking about the organization process, we're talking about the process. So think about this and muse on this, and I'm sure you must be doing something very interesting, but I'm quite sure it's also a fodder for thought. Thank you so much.